so I got some, just kind of an introduction to the topic. The things I want to talk about came up mostly, or they have come up every time I've taught my philosophy of science class, which I taught just last semester. So some of the students from that class are here. This will sound familiar to you, some of these things we're going to discuss. And I can promise you this talk or this discussion will be completely and totally apolitical. It's just about science, okay? And about philosophy of science. So I want to start with just telling a little story. I have in my office a book that's called Particles and Paradoxes, The Limits of Quantum Logic. Sounds gripping, doesn't it? But I want to give you a quote from the preface to that book. The author's name is Peter Gibbons, and here's what he says. The philosophy of quantum mechanics deals with the question, what is the way the world is if quantum mechanics is true? So I have to confess that my first thought was actually quite thoughtless. I thought I'd let it pass, that it was a harmless sentence. But then I wondered, mustn't the answer to his question, what is the way the world is if quantum mechanics is true, mustn't the answer to that question be no different than it is now? How can the truth or falsity of quantum mechanics determine the way the world is? Now, the world might change, of course, the more we understand about the application of quantum mechanics. I think this has happened, right? New technologies using quantum computing and so on. So there, might be things that change in the world due to the application of quantum theory, quantum mechanics. But these are questions about how the world will be, not questions about the way the world is. And the condition is different too for the changes that I mentioned. I asked what might happen if we understood more about the application of quantum mechanics, but Gibbons' conditional is if quantum mechanics is true. And in any case, it's not at all clear what the world means in his sentence. It's likely that it means something different in Gibbons' question than it does in mine. My guess is that what Gibbons has in mind when he talks about the world is something like physical reality or the empirical universe. But of course, taking him to mean something like this is what led me to my original puzzlement. So let's take his meaning for the moment, at least, as what I think he means, physical reality or the empirical universe. And here's what makes this question so puzzling. The criteria we use for either accepting or rejecting the theory of quantum mechanics is whether or not it adequately explains what we do observe. If it cannot do this, if it cannot account for the way the world is, then it cannot be true. And by true here, I mean something like it's not accurate. True or accurate. There are other related but not identical uses of that word true. But now I can hear someone say, but isn't the quantum world a different world? Maybe. What does one mean by this? The quantum world's a different world. In one sense, it cannot be a different world, for it would be no world at all. It would be science fiction. I think, isn't there a brand new Avengers movie coming out? Ant-Man and Wasp. And they supposedly go into the quantum realm. Gee, won't we all be enlightened? Now, maybe you mean something like that. Quantum theory is a theory about how it is that the actual physical world works. And that's something we can see for ourselves. If quantum mechanics cannot explain why I get a shock from my refrigerator after walking across my carpet, or why the sparks fly between the terminals of my battery when I bathe it in ultraviolet light, then I have some reasons for rejecting it. But in another sense, I suppose you could kind of use this language. It might be true in one sense that the quantum world is a different world, for it is a world populated with probabilistic wave functions rather than determinate objects, massless particles, ghost-like action at a distance. To say this is a different world is simply to point out the different uses that we have for these expressions. We can see this more clearly when we realize that these latter expressions, probabilistic wave functions, massless particles, action at a distance, and so on, are properly understood only if we learn them as part of the theoretical explanation of quite ordinary, easily observed events. If we're to ask a physicist what he means by saying that ultimately all physical objects and events are made up of probabilistic wave functions, he would have to answer by showing how these probabilistic wave functions provide the best explanation we currently have for what we observe happening in much of the world that we live in, even though it is true that a lot of us live in our own worlds. No laughter. So the quantum world, if we can make sense of this at all, might just mean living in the language of the quantum physicists, speaking their language game. Maybe that's what it means to live in the quantum world. You're surrounded by quantum physicists, and you learn to speak like them. So Gibbon's remark is still quite puzzling, even making the best guess at what he could mean by the world. Still, it is a revealing remark, for it shows the characteristic approach of many contemporary philosophers of science, of physics. It shows what they think their job is, to try to determine or help the physicists determine the way the world is. There is apparently something unsatisfactory about a mere description of the way the world is, something that calls for an explanation of why it is the way it is. That is, there must be something hiding behind the way that the world is that explains why it is that way. And this, the hidden explanation, this is the way the world really is. So, I want to stop with kind of an introduction there and give you some cases and see if we can figure out what's going on here. So these are real life cases. These are things that people have actually said to me. Okay, I'm going to start with the first one. Actually, nobody said it to me, but it's a famous story about one day, two famous philosophers, Bertrand Russell and Ludwig Wittgenstein, were having an argument. Russell was expounding on atomic theory, and they had an argument about whether or not the table they were standing next to was solid. So Russell tried to explain to Wittgenstein, look, at the atomic level, it's mostly space. Right? Everything's made of atoms. The particles, if you can call them that, within an atom are very, very small. And there's a lot of space between them, and even more space between each atom. So the argument got heated until Russell actually stood up and said, "The table is not solid." And that's exactly what Wittgenstein did. He laughed. So why would anyone think the table's not solid? Atomic theory? Yeah, that's why Russell thought the table was not solid. Here's another case. Somebody actually told me this. I was, as an undergraduate, I was a physics major, and I emphasized in astronomy. So someone once told me, when we were talking about observing stars, he said to me, "You don't actually see the star. You see the light from the star." My next question was, well, where's the light from the star? I think the star is up there, but where's the light from the star? If that's what I actually see. And now, of course, I suppose you didn't have various answers to that. Well, it's got to reach you, right? The light. So, is the light here where it enters my eye? Or do I see it at the back of my retina? Or is it all in my mind? Tough questions, huh? Another one. This one came up in our philosophy of science class. We read Darwin's Origin of Species. And Darwin is pretty clear that there really is no distinct way to tell one species from another. There's just gradations, you know? And you get a new variety, and whether or not that's going to be a species, it's hard to tell when that happens. How many of them do you need? How long do you wait? How different does it have to be before it's a different species? So I've actually talked to one biologist in the past, who's no longer here, who actually said, well, there is no such thing as species. Okay. Here's another one. How's that coat? Is that a warm coat? There are no warm coats. So next time you go to the store, don't ask for a warm coat. Why might somebody think there's no warm coats? Coats aren't warm?
Because the coat doesn't actually produce the heat.
The coat isn't warm, you are. No, you're shaking your head. I'm glad that you're sort of, there's something odd about these cases. Isn't there something strange about each one? Here's another one. This was actually, now I know advertisements aren't the best source of truth. But there was once an advertisement on the radio for a talk show program that was led by a psychologist, I think. And in the advertisement, you hear him saying, love is just a neurochemical process. And ironically, the ad ended with inviting people to fall in love with Dr. So-and-so. Listen to his program. But you can think about this with any emotion, right? What's the chemical that supposedly produces?
Oxytocin.
What is it? Dopamine?
Yeah.
What is that? What it is?
Oxytocin.
Yeah.
Oh,
that's the
oxytocin.
cuddle.
Thank you.
Cuddle
I'm no
hormone.
expert in that.
You're good.
So what do you say about that? Emotions are just chemical processes, neurochemical processes. Again, this is something I've actually heard people say. Here's another one, more from the social sciences. You are a product of your environment. In reality, you don't make choices. You're conditioned. Another one, somebody actually told me this, another faculty member. All relationships are political relationships. And I asked, is that the kind you have with your wife? And he said, yes. So now, I think there's something in common, a common mistake behind all of these examples. What's going on? Why would Russell say the table's not solid? Because when you think about it, atomic theory is supposed to explain why tables are solid, isn't it? And if it can't do that, then we don't accept it as a viable theory. Am I right? If some kind of theory in physics leads you to think that you don't see the star, something's gone wrong. Because after all, any theory worth its salt should explain why it is that you see the star. Right? And you could do this with all the others. I mean, after all, the title of Darwin's book is The Origin of Species. And so now if you got some theory that says there isn't any, Darwin himself struggled with this. He wasn't quite sure what to say. Later in the book he says, but there have to be species. How can we do biology if you don't have some kind of categories? The other ones, you're a product of your environment. Basically, no freedom. Everything you do is determined. You're conditioned. But wait, shouldn't a psychological theory explain why you do choose what you choose? Why do you make the choices you make? Well, it might very well be that your upbringing and your raising have some influence on your choices, but if you now have a theory which actually eliminates the very thing which it's supposed to explain, then something's gone wrong. Does that make sense to everybody? So I want to kind of throw this out here for you to think about. Oh, that's terrible chalk. Let's get this better. So by grammatical confusion, I just mean you're using the wrong word. You're conflating two things, two words, equating them when they should not be equated. Now, I think actually this is a tendency that you see in all kinds of places, not just in science, but especially in science. It seems to be problematic when you conflate an explanation, take it as a description, then you're gonna run into these kind of problems that I've just been talking about. The very thing that's supposed to be explained gets nullified when you take the explanation to be a description of how things, quote, really are. That makes sense to everybody? Okay, at this point, I just wanna open up questions, see if maybe you got some other examples where this kind of problem occurs. Yes, no, you're awfully quiet.
So just to take your example about the solid table.
Yeah.
As we talk about this in chemistry, that basically there is a lot of quote empty space between that's what the theory
Sure.
kind of holds for. And there's experiments done, right? There's some experiment done that demonstrates that this kind of concept, but the explanation of the empty space comes from trying to interpret this experiment. So there's, you have the experiment, you have some results, and then you basically, you're coming up with an explanation and say, aha, when I do this, it appears that matter is made up of mostly empty space between these tiny particles with charge and so forth. I think that the more complex systems get, the harder it is to really describe them, and you're more likely to get
Right.
these kind of grammatical
Right.
confusions.
Right.
What do you think about that?
Well, I think, you have a further problem, not just mistaking an explanation for a description, but also, if you say there's mostly space between atoms, or even between electrons and the nucleus, are you using the word space in the same way that we normally would?
That's a good point. We really mean distance.
Yeah. Okay, relative to the
We
size,
also-
I don't know, can you even talk sensibly about the size of subatomic particles? I mean, really, can we? How big is it? How would you measure such a thing? Now you can measure certain features of an electron, of a proton, charge, spin, what are some other things? But even, well, this is gonna get us into the next part of what I wanted to talk about, but they are obviously very related. So the other part of what I wanted to get into is not only talking about this important distinction between an explanation and a description, but also talking about the different roles in science of between imagination and observation. So when I was a high school student, and I think this is true even of a lot of people even today, you got a model of the atom, and it was like a miniature solar system, right? You got these little, I love it, the protons and the neutrons, they're round in the drawings, right? You got a model, and then you got the electrons, and they're round too, but they're a lot smaller, and they orbit around the nucleus. Okay, is that a good way to think about it? Because if you talk to a physicist who studies this kind of thing, he would say, no, they're not really particles, but they sort of are and sort of aren't. Subatomic particles look sometimes like they're waves, and sometimes like they're particles. I remember thinking, one of my teachers said, let's just call them wavicles. So what we have here is you imagine something, but this kind of imagining is picturing. You form a picture. But I think any nuclear physicist would say that's a misleading picture. Right? You might even say something like, that's not how it really is. And then, of course, you want to ask, well, how is it really? Now, if you're still looking for a different picture, that's still not going to help you. Are you following me or not? I mean, I remember this. I took a quantum physics class, and we didn't get pictures at all. We got equations. And I remember being so frustrated and confused because I wanted to know, what does it look like? And the answer is, you can't put it in terms of what it looks like. You just can't do that. So now you have this explanation, which we call, quantum mechanics, a theory, but you can't picture the things in this theory. If you try to picture them, you're going to be misled in one way or another. And so we have this expression that I actually mentioned at the beginning. You've got, how did I put it? That expression? Probabilistic wave functions. What's an electron? It's a probabilistic wave function. Picture it. Can't do it, right? Squiggly. It's cloudy. And that's what you'll get. I mean, if someone says, okay, really, what is it? Well, that's what it is. The electron is a probabilistic wave function. And you go, what? Draw one for me. And you do that, right? The squiggly line or the cloud. See, none of those pictures serve. But now let me ask you, if you can't imagine it by picturing it, is there a different sense in which you can be asked to imagine something? Another thing I did when I was younger, still do sometimes, when you work on electronics and you're trying to figure out where maybe a short is in the circuit or something like this, and so you look up something to try to see. And I've been frustrated by this too. My car has an electrical problem. There's a short somewhere. I want to know where it is. And so I look up the schematic. You all know what a schematic is? The schematic does not tell you where things are in your car. It just tells you how things are connected. That's another way I think you could make sense of imagining something. You put together a schematic. It's not a picture. It'd be more like a chart or something, or maybe more like equations. Right? So when we offer some kind of hypothetical explanation, here's might be how this works or why it works this way, is it necessary that a scientist be able to picture it? And I think actually that can sometimes be a problem. It certainly is with quantum mechanics. If you try to picture it, you're going to be misled one way or another. I mean, if you're actually working with the equations and so on. And the same is true. I think a lot of people have had that. Anybody else? Am I the only one? Tried to fix an electrical problem and all you could find was the schematic, and that didn't help you at all. Okay, so this fuse is connected to that device, and all I got on my schematic is a line connecting them. What I really want to know is, where is that line in my car? Okay, where does it go? Where is that fuse? Where is the device that it's connected to? Well, the schematic isn't going to help you that way at all, right? However, if you're an electrician, you can read the schematic and you can figure all that stuff out, and you don't need a picture. Does that make sense to everybody? So and I think of course it is important. I don't think you can do science without using imagination, but seems to me that ordinarily the kind of imagining that scientists do is not so much picturing, but it's more like this schematizing. That makes sense? Other questions? I feel like I'm talking too much here, but yeah.
So the schematic is an explanation.
Yes.
And the mistake is taking it as a description.
Right.
Now,
So
I have
there's
a question for
there's
you.
two kinds of problems here. One is the tendency for imagination to always be the same as picture.
Right.
I think that's misleading in science. But then also the problem of mistaking when you've got an explanation versus a description. Is that,
Yeah, that's what I was thinking.
yeah, other questions? Yes?
Well, I just have a comment. It seems like a lot of times when, and this I think is true in kind of general, when people are arguing or discussing something, a particular thing, neither one has defined what they mean.
Yeah.
So, for instance,
Yes.
with the table, neither person defined what they meant by solid. If solid means that if I hit it, it's not gonna fly into pieces, that's one thing.
Mm-hmm.
Both people should be able to agree that if that's the definition of solid, then the table is solid. But if the definition of solid or unsolid is that there's a lot of space between things, both people should be able to agree that that's true.
Well, maybe, although I think Wittgenstein would have not agreed that the table is mostly space. You know, you can kind of imagine this. Really?
Well, it doesn't look like it.
Right?
Things aren't always
Right?
like
Yeah.
they look.
No, they're not always. Clouds, they look solid, but they're not. Sure. But you can tell that by just getting closer, walking through it, flying through it, right? What a world that would be if clouds were solid. Right? You'd hit it. Yeah, I get you, and I do agree that it's important to have agreement about how you're using terms. Yeah. Any other questions at this point or comments or, yeah?
Is there any instance where an explanation and a description could be the same thing?
Yeah, I was gonna kind of lead into that. Not simultaneously, I don't think. It can't simultaneously be a description and an explanation. But there are times which something which was previously part of an explanation now becomes something which you can describe, and it requires further explanation using something else. So I'm going to give an example that Dr. Jensen knows a lot about. This is not the one I mentioned before time, but I mentioned this in actually my metaphysics class today. In the mid-1800s and prior to that, astronomers thought there were only, let me see if I get the number right, 7 planets? Mercury, Venus, Earth, Mars, Jupiter, Saturn, that's 6, and Uranus. Okay, Neptune had not yet been discovered. However, astronomers who had taken a lot of measurements and I've made a lot of observations over a long period of time of Uranus noticed there was an anomaly in its orbit. And this was a periodic phenomenon, right? I don't know exactly what they observed. Do you know what they would observe? Some kind of change in its position. Very slight, but something you could see. And so now, as all scientists do, you notice a phenomenon that you can't explain, so you come up with a hypothesis. What might explain that? Well, what might explain it? Yeah.
Gravity.
Yeah, perhaps it's being affected by the gravity of another object, right? So if you can see when this happens and look around nearby, maybe you'll find some kind of object that's relatively close to it that's affecting its orbit through a gravitational pull. And indeed, that's what happened, right? So they started looking at in the sky at Uranus, around it, and sure enough, they discovered a new planet, Neptune. Now, prior to the actual observation of Neptune, I think it would make sense to say this planet wasn't named yet. Let's call it X, Planet X. I love that. Planet X was just a theoretical object. We didn't know if it actually existed or not. Right? So, supposing it exists is part of it being an explanation. However, once it gets discovered and observed, it's no longer part of the explanation. It can now be part of a bigger description of the solar system. Does that make some sense? Now it is a little bit tricky. I guess you could say, well, it still does explain. Yeah, but it's no longer a theoretical entity. Right? As far as we're concerned, it's no longer just a theoretical entity. Now we observe it. And I think that kind of thing can happen. So what was previously part of an explanation can later, after discovery, after observation, become something you can describe. Does that make some sense?
So you can explain what you don't know, and then you can describe what you do know.
Right, right. Yes.
But I think you're making too much of a distinction between observations and explanations. In that even when the aberrant behavior of Uranus was observed.
Yeah.
So to that extent, we're observing something is affecting Uranus, just like something is affecting my retina when I see the light from Neptune.
Sure.
We haven't actually put our hands on Neptune and.
No, right. Although we have spacecraft that have gotten close. Yeah.
More facts about Neptune now that we've actually seen the thing.
Sure, but I would say the aberration is something you do observe.
Right.
And then you theorize that there is something causing that. But you don't yet know what it is until you see it.
Well, just as
Observe
I
it.
theorize, the thing that's producing the light that's impacting my retina is the planet.
I'm not quite sure I understand that.
Okay, I mean, in both cases, we're observing something.
Right.
In the case of actually seeing Neptune, we're observing it with our actual eyes.
Right.
But nevertheless, how do we know there aren't space aliens out there, broadcasting something that looks like a planet?
What? Broadcasting something?
Well, the space aliens beaming light at the Earth to make us think there's a planet out there when there's not.
Oh, well, yeah, we don't know that that's not happening.
So in other words, we're observing in either case.
Well, we could find that out,
Right.
right? And then we would observe what it really is.
Right.
Right? So, I don't know, I think the distinction still holds. Once you discover that there is something there and what it is, then you can describe it. But prior to that, it's part of an explanation.
I believe, okay, my history of astronomy is rather weak, but I think even the existence of Uranus was first conjectured because of oddities in the orbits of the other planets.
Yeah, I don't know. Was that? Do you know if Uranus was discovered the same way?
I don't think that's true.
I think Uranus was a object that they actually saw.
Yes, discovered by Herschel Walker.
Herschel Walker?
Not that one.
He's discovered a lot of things we never knew about.
Herschel, there was John, William, and Carolyn.
Yeah.
I want to say William.
Yes.
Okay.
So, but that was a chance because he was scanning the sky for all
Right.
sorts of stuff, and there was he stumbled across Uranus by chance,
Right.
and then Then there was orbital anomalies in Uranus that led to the discovery of Neptune. And then there was the belief that there were orbital anomalies for Neptune, which led to the search for Pluto.
Right.
And Pluto was so small that it doesn't really explain much, and further refinement said, maybe there aren't these anomalies with Neptune after all.
So that would have been kind of a chance discovery as well. Pluto.
Yeah, Pluto was definitely kind of a chance discovery because it's big.
Fun fact, I grew up in the town where Pluto was discovered. Yeah.
So how does your town, how does that town feel about when they declassified it?
Oh, I was moved away by then, so I'm not sure. Yeah. Yeah, if you don't think Pluto's a planet, don't go to Flagstaff. I'm kidding. But my point is, I think that something which is an explanation to begin with doesn't always have to be something which is an explanation, is part of an explanation. Compare, the planets situation with something like quarks. Now, what could it mean to say that you see or observe a quark? I don't know, maybe somebody else knows more about this than I do. How do you observe a quark?
Well, usually I start by grabbing the bottle.
Yeah. Do you have a favorite subatomic particle? Mine is the intermediate boson. Anyway, just kidding. Do you observe those things?
So by definition, we don't observe them in the same way that we are
No.
with each other because
You
how
can't-
light is produced.
Right.
how
You
light
can't
is
even
produced.
use a microscope.
We're probing, to go to your question, much earlier, we talked about the size of the particles.
Yeah.
There are ways we can probe the region of influence or
Yeah.
how they interact.
Yeah.
Right, that's really what we are, that's what we mean when we talk about their size.
Yeah. Yeah, I brought that up because one of my questions, really for discussion, was if this interaction between explanation and phenomena that's observed can change like that. So what previously was just part of an explanation is now something you can actually describe and observe. Is there kind of a limit? See what I'm after? So maybe subatomic particles will always be unobservable and yet always something we rely on for an explanation. In other words, they are sort of, how should we say this, destined to always be part of an explanation and never something which you can actually observe or describe in any exact way.
With faith, like just believing that it's there without proof.
No, I don't think it's a matter of faith. I just think you say, okay, this explanation it works. It does explain all the things it's supposed to, right? But maybe the elements in that explanation, like these particles, are something we may never be able to observe directly. Now, that's not so much faith as it is, hey, it's an accurate theory, it's an accurate explanation, it's perhaps the most accurate one we've had. So that's reason, isn't it, for accepting it? So it's not really like saying, well, I don't know, it would even be odd to say, I believe in electrons. And how has that changed your life? you know, you see what I'm saying? It's not like those are things you can believe in. But faith is usually, you know, I believe in
Things that
God,
you
or I
can't
believe in,
see.
right, you know, well, there's some similarities, I guess, but it seems different to me.
Yeah.
Yeah. Go ahead.
So can you say that something is truth if you can only explain it but not describe or observe?
Well, I think you can use the word, but you'd have to be clear that your use of the word is something like, this theory is true means it works, it's accurate. It does adequately explain what it's supposed to explain. There's this, I don't have a problem with anyone saying, well, that makes it true, but you do have to realize that's a different use of the word truth than, say, for example, today is really cold. Is that true? Yeah, that's true, right? That's not an explanation. In other words, what it means for an explanation to be true is different than what it means for, say, a proposition to be true, or a description to be true. Does that help a little bit? And it's actually quite different than what you might mean by saying that a person is true. You ever thought about that? Are you true? I actually read a great novel once where the main character is confronted with this kind of prophetic-like person. And he comes right up to him and says, "Be true." That's all he says. And he kind of shakes this guy. What does that mean? Well, I think you know what that means. We all know what that means, don't we? Be true. Be honest. Be the kind of person people can trust. Right? Always live well, good. Seek what's virtuous. Be true. Now that's, of course, quite a different use of the word true than saying that this explanation is accurate. That makes sense?
Yeah.
Other questions or observations at this point?
Do you think like dark matter is
Yeah.
akin to like these like ever smaller subatomic?
Yeah, that's a good one to think about. Dark matter. Do you guys know what that is? Has anyone seen it? That's what's in the corner of your bedroom when you turn your lights off. Dark matter. My pile of laundry. I mean, that's a joke because it's dark, and that just means we haven't observed it. Okay? I would say dark matter is a good example of something which is part of an explanation, but not, or at least not yet, something that can be described. We haven't seen it. We can't make direct measurements of it. We can make indirect. In other words, we infer its existence. Yes, no, am I on the right track, on the wrong track? I'm especially looking at those of you who know about dark matter more than I do.
Well, that's what I was thinking of too. Dark matter is part of the explanation for why the universe is expanding at the rate it's expanding at.
Yeah.
But if you go into I'm gonna make a dark matter reactor and that's gonna be able to have enough energy to get us to the stars, now you're pretending that this is a real thing that you can get a hold of, you can describe, you can do something with, and it ain't that at all.
Right.
So,
Yeah, I was trying to explain it to my son after he's watched Flash. So many episodes
Oh.
of Flash where dark matter is in Flash, but you can see it in.
There you go. Oh, that's kind of a funny question. So if we actually find some, don't we have to rename it? Not dark anymore?
Invisible probably. a better word.
Invisible, yeah, okay.
Because you get confused with, there's lots of stuff in astronomy which is black,
Right.
right? It doesn't count for what we're talking about when we talk about dark matter. And there's actually a couple of different senses in which we use the term.
I'm not sure what it would mean to look for it. That's the thing.
Yeah.
Look, the reason you have it is you need this to explain the equations, right? Of how the vast universe is
Or to
expanding.
explain other observations.
Yeah,
you
Yeah,
say.
that's what you need it for. Now, what does it mean to go look for it? You've got it in the equation. It's that's where it is, insofar as it is anything.
Right. Yeah. Right. Yeah, the one that's even more puzzling to me is dark energy. That one puzzles me a lot. Because
So-
isn't energy something which you can, by definition, see? Somehow observe?
I think that was tricky. I don't always agree with Neil deGrasse Tyson. And here's one way I think that he thinks that we shouldn't call dark energy dark matter. He thinks we shouldn't call it that. And I think he's half right, maybe, because
Does he have a
with dark matter, there's at least a case to be made from these observational inferences that it is matter. That seems to be a better explanation than some modification of the laws of gravity, for example. But there is there is something with substance.
Right.
Dark energy, that's just a term that describes a phenomena that it may or may not be energy at all.
Right.
There's no particular reason to think it's energy other than in the most general sense. Whereas with
Right.
dark matter, it's different. It's still a lot that's unknown.
It
about
functions like mass does.
Yeah.
So that's why you think it's
Yeah.
more solid.
Well, I agree. I think there's a difference between those things. The one makes more sense to me just because it actually is performing some kind of explanatory function. I guess I just don't know enough about dark energy and what it's supposed to explain. But anyway, yeah. John?
It seems like what you guys are saying is maybe you'd be hasty if you tried to form a picture of these concepts. Like the concepts are
Yeah.
Purposefully not ambiguous or vague, but purposefully general. And because it would be wrong to
Yeah.
form a specific picture of what they're meant to function as, right?
I don't know, maybe. If I can, I want to switch to another example. So I think a really good example of the conflation, I know I'm going to get the pushback on this, of the conflation between explanation and description can be found in Darwin's theory that evolution takes place by means of natural selection. So those of you in my science class can maybe help me out. We spent an awful lot of time trying to figure out what Darwin means by natural selection. So putting aside for now the obvious misleading analogy here, supposing nature selects, that's really kind of a grammatical mistake, right? Nature's not an agent with choices and things like that. That's just kind of a wrong way to speak of it. But putting that aside, Darwin most often describes, or defines, I should say, defines natural selection as the preservation of favorable species, and other times he includes in that the extinction of unfavorable species. And by favorable, he means those that are most likely to survive. Okay? I think everybody's fairly familiar with this, right? Now the question is, Darwin clearly states that he thinks that's the explanation of what we see, species evolution. That explains it. However, when you look closer at it, it seems like saying favored species are preserved and unfavored ones are exterminated is simply a description of what we see. So here's the question. I actually bring this up every time I teach Darwin is natural selection meant to be an explanation of something? Or is it something we observe which is in need of an explanation? You all see what the question is? I mean, in logic, you just kind of put it this way. There's the thing to be explained, the explanandum, and then the thing that explains it, the explainens, I think that's the term. So, natural selection, which is it? The thing to be explained that we actually observe? Or is it the explanation of what we observe? Now, whichever way you go, you're stuck with this problem. What's the other thing? If it's the thing that's supposed to be explained, then what is the explanation of it? And if it's supposed to be the explanation of something, well, what is it that it explains? You see what I'm asking? So, I don't know that I've ever heard a good answer to that question.
So what is, like, what is an example that Darwin uses for this? Like in the origin, does he address like the finch beak size or something like that?
Sure. I mean, he gathers all this data, all his observations about the finches, and he notices this version of the finches, because of their beaks, they are able to survive, and the ones with different kind of beaks that are less suited to their environment puts them at a disadvantage, and then eventually over time they'll die out. But isn't that just what natural selection describes? The preservation of favorable species and the extermination of unfavorable ones? Now look, I'm not saying this is not a challenge to the theory of evolution as a whole. It's just one part of it. Okay? And I think I've actually talked to quite a few modern day, well, Don, Simon, and others who are evolutionary biologists. It's interesting to me that since Darwin, there's been less and less emphasis on the role of natural selection in species formation. And they're relying more on other kinds of factors like genetic drift and mutation. You tell me, I mean, you're a biologist, right? I think I remember her saying that in our class when she came and talked to us.
Well, then there's pairing together. There's always this pairing together.
Right.
Mutation and selection.
Right.
Mutation and selection.
Right. It's I haven't heard anybody just kind of give it up. Actually, I've heard one biologist who has actually said, this is too confused of a concept and it's not usable. Yeah. He's written a couple of books. His name is Richard Lewontin. But anyway, do you all see? I just want to. I'm throwing this out there as an illustration of the importance of making a distinction between what this thing is supposed to be either an explanation of some observed phenomenon or a description of this observed phenomenon. It can't be the same thing at both times. Yeah.
So maybe you already explained this and I just missed, but why can't natural selection be the explanation for a species? Cause didn't you say there's a problem with that? Or like there wasn't an answer?
It's supposed to be the explanation of why
Why species?
you have these species and not these.
That's what Darwin says,
Yeah.
natural selection. Were you saying that you disagreed with that, or like that's not an answer?
It seems to me that that's actually what natural selection describes. That is a description of what is in need of explanation. In other words, I'll kind of put it this way. So if I say, look, some varieties survive long enough to become a species, and they proliferate and have offspring of the same sort and so on, and other varieties don't. And sometimes what also happens is these new varieties kind of shove out the lesser, the ones that are not as fit for survival, right? And they become extinct. Well, yeah, that's what you can see. You can observe that. If you have long enough time and enough data, you can see that's what happens. Now, I'm not questioning that. I happen to think Darwin's right about that. Right? And he should be honored for seeing that when other people didn't really notice it. Correct? But now, you want to ask, okay, why does that happen? Why does that species survive and this other one doesn't? And now if I come and tell you, the reason is because over time, some of them survive and other ones don't.
That's exactly what you're trying to. Got it.
But
Yes.
now you see where I'm going?
Yes.
Now, I don't know, am I off base? Have I got this wrong?
I think you're right. I think it is, maybe part of what makes the topic so contentious at times too, because it seems like there's a lot of sort of, because life is such a broad thing, you can't, it's very difficult to have an example of every selection and mutation event. I mean, it's
Right.
basically impossible
Right.
to have a description of that. It's almost like you're dark matter
Yeah.
in some ways.
Yeah.
To have a description of every selection and mutational pairing. So we get this kind of like almost circular kind of reasoning, and people, I think that might lead to some of
Right.
the confusion.
It makes more sense to me to say something like, well, the reason you have these species that survive and these that don't is to be kind of specific about that case. Well, why did that one survive? Well, because the environment changed so that they were, that this feature, or they developed this feature. Well, how did they develop it?
Accident.
Mutation? Maybe accident? Right? Maybe you could explain it at the genetic level? Right? I guess you would have to, right? Isn't that where
Yeah.
mutations, where you find them? Well, I'll give you an analogy. It's almost like you watched the Super Bowl and you said, okay, Kansas City won the game. Now, why did they win? And not, who was the other team?
The Eagles.
Not the Eagles.
It was that one.
And now, what if your answer was this?
The Browns.
They scored more points. Chiefs scored more points. That's an explanation of why they won?
There's the refs.
Yeah, whatever, okay. That makes more sense. I mean, not that it's the right explanation, but it makes more sense because now you actually do have an explanation of something. But if I just said, well, they won the game because they scored more points. That's not an explanation. That's just another way of describing the same thing. Right? So, I don't know. I hope I'm not on anybody's blacklist now.
Well, I think this is a really good example because it just explaining things is hard.
Yes.
And that's where I think that your point is really good there.
Yeah.
And then the more complicated or more complex something is, the harder it is to explain.
Yeah.
Like explain weather. Right?
Yeah. Yeah. Good luck with that, right? Well, any more comments? John?
Would this be another example of where the two get confused? You've got this question of, well, how is it that we're able to understand something, or remember something, or perceive something? And we've recognized that the brain plays a vital role in being able to perform these functions. And so we look at the brain and we see what it does, and then we start describing it as
Right.
remembering things.
Right.
Your brain holds memories,
Yeah.
or your brain sees an image.
Yeah,
or
I think that's right.
represents.
I think that's another example. So, let's say you're in a lab that's, people are doing brain research and so on. And they ask, look at that object, that picture on the wall. And then they take a scan of your brain while you're doing that. And then they come and say, okay, this scan of your brain, that's seeing the picture. No, I mean the brain scan might be part of an explanation of how you can see the picture, but it's not seeing the picture. It's as if the brain scanner comes up and says, this is what seeing a picture really is. Really? What it really is? Yeah, I think that's a good example. I was thinking also about the love is a chemical process thing. So if you can map out that process, describe it in detail, and then use it, you can make people fall in love with you.
Actually, it would make things a lot easier.
It
You
would.
just take the chemical, you don't have to worry about
Right.
the
Forget it, right? I want you to love me. Take this. I know it. That's right. I believe love potions are the same as snake oil, right? Other questions or comments? Okay, obviously my field of expertise is not philosophy of science, but hopefully I've given you some things to chew on. Another question, maybe just to end it, is, because I was thinking about this, so are these mistakings really serious? I mean, what's the consequences of doing this? Someone might say, so what if someone says you don't see the star, you just see the light from the star? What's the harm in saying that? Right? Or so what if someone says the table's not solid? What's the harm in saying that? Well, what do you think? What is the harm in saying that?
Makes it hard to communicate with each other. We're all talking about different things.
Sure. Could it have, for example, practical consequences?
Yes, I
Like,
could slap you and you could not sue me.
Like
I
this.
can't hit you with anything solid.
I'm gonna sit down, but, oh, wait. Will I hit the floor or not? Right? I'm not sure if that's solid. Yeah, John?
I'll, do some science and go home and tell my wife I chemically process her.
Yeah, it can happen there, right? Yeah. If you wanna get slapped or shunned, tell someone that, I love you, but it's just a chemical process. Any other consequences? Actually, I think there are more serious consequences. For example, if I suppose that I really don't have choices, is that gonna affect how I live? Actually, I'm wondering if I could live. I mean, after all, what do I do?
Don't have to worry about it, it's not you.
It's not me. I don't actually do anything, I just let stuff happen. Okay, well, I've talked enough. Thanks for your attention, for your cooperation, for your comments. Anything else?